clays and 1 hoku. Alright? Last. So let's go forward. Could you answer Franck, please?
Okay, thank you. Ultimate solution, eventually, for presbyopia correction, bionic eye. Let's go to this topic. Presbyopia, what do we want to achieve? What have we already achieved? What's still to be done? What do we want to achieve? We want to replace a natural lens of 60 years old by an artificial lens performing like at 20 years old. That's the idea. Artificial lenses, we have heard so much about it this morning, this afternoon, yesterday. Probably too many to be good. When did they start with phacoersatz? It's not a few hundred years ago, but it's already a long time ago. Jean-Marie Parel was the first to start with it in 87. And then in 1980, Jean-Pierre encountered the first two-zone reflective multifocal. We were starting with the 3M, we did between 200 and 300 of them around 1990. Again, it's many years ago. The 3M with the upwardized principles, 6-7 millimeter opening, no foldable lens, a lot of astigmatism, but these patients were happy but much less demanding. Then we'll go quick over the evolution, the true vista, the array, the resume, the restore, the deck base, the new additive multifocal, the circoflex, the add-on, segmental multifocal IRO design came in, the lentis plus, the oculentis, it's a new third technology, this TPC confirmation 2009. The so-called accommodative IRLs, they did not work, they worked in the US, they didn't work in Europe. The crystal lens, the add-on, the tetraflex, the 1CU. Toric multifocal lens, another improvement, they come into the market, the first model, the Rainer, the 8 laser, the lentis correctly soft restore, etc., etc. The circoflex, the add-on human optics, the Kreuzner, the theoretical idea, the magnet-driven shift IRL, newer generations, again new, better improvement, dual optics, paparazzi, new lens curve. It seemed to be the ultimate solution. They are working since 6-7 years on it. It has to be placed in the surface. I don't know where they are at the moment, but they studied it during 6-7 years. The power vision lens, the fluid vision lens, it seems to be an improvement. But is this the ultimate solution? Bifocal, trifocal lenses? No, it's much better, but still not good enough. So maybe we need another approach. The original approach, you see in 64, we have the first publication on how to make a new and a better injectable lens. And it was published in the Journal of, in the Archives of Ophthalmology by Keller. Some major problems remain when we want to make a gel lens and to implant it to 1 millimeter. And the most important problem, of course, is PCO. Then we have to open the capsule, leakage of the injected gel will happen. So probably we'll have to go the other way. Maybe we have to follow the mechanism of the bird's eye, as we can see here. Certain diving birds have a method of altering the curvature of the front surface of the lens. They are able to squeeze the lens into the constricted pupil using a powerful extraciliary muscle, Bruch's muscle. We don't have it. It's unfortunate, but it could be very helpful for us because they can generate 80 diopters of extra power using this mechanism. Maybe we have to go another way and we have to make a bionic man with the bionic ideal phacoersatz. As you know, the bionic man already exists. 80% of the body is replaceable by prosthesis, and sometimes we'll make it better by giving them prosthesis. Cyborg, you see it here. What's a cyborg? It's a being with both organic but biomechatronic parts. Here you see a robonaut and an astronaut working together in the International Space Station. You will not see the difference, but because one of them is a man, the other is a robot. Maybe we have to go that way. Anthony Atala was using 3D printing. That's maybe another way to go. To print a human kidney, you see it here, the human kidney, it printed already a bladder, he inserted it, and the patient is living and is functioning with a 3D artificial bladder printed by him. Let's see if, what I wanted to show with this slide, Oscar Pistorius, he may be in jail in a few months. I will not show the whole video. It's the Blade Runner, and he came into the semi-final at the latest Olympic Games with this prosthetic device. And what happened, the Olympic Committee has to make new guidelines because athletes with prosthetic artificial shoulders, legs, arms sometimes may perform better than normal beings. So they have to take some measurements. We're already capable of making robots that run faster than Usain Bolt. As you know, Usain Bolt is running very fast. So we can do so many things. We can even make a bionic eye, but not yet an ideal implantless. 3D printer was able to print also functioning ear, as I showed here. And Chinese scientists are 3D printing ears and livers with living tissue. Specifically modified 3D printer use live cells that could theoretically be transplanted. 3D printers can be used to create eye cells, which we just believe will help the search for a cure for blindness. Maybe that's another way to go. So, what I would like to show you that we made an enormous amount of progress. The idea of creating an ersatz lens and to replace the accommodation of 60 years by the accommodation of 20 years is not new. They are working since more than 50 years on it, but the ideal solution is not yet there. Maybe they have to try to copy what some animals are doing, maybe they have to go to 3D printing, maybe they have to go to prosthetic devices using bionic man. Thank you for your attention.
Thank you very much.